Okay, well, it's kind of a limited amount of time, so why don't we get started? And I think this is being recorded, so it's possible for people to go back and look at the beginning of this if they need to. But this session is entitled Global ARD to Local DRI. We'll understand by the end of this what those acronyms mean and what they mean to each other. So this is basically a report on the work that was done in the Open Geospatial Consortium Disaster Pilot 2021. And I'm not actually going to talk much about the Open Geospatial Consortium. I'm going to assume that most of the people here are pretty familiar with it, but I'll say just a couple brief words. And a large part of the mission of that pilot was exactly this value chain and data transformation to information, to indicators. And so we'll be going at how that's done, what components and information architecture are valuable for that, and this really essential piece in there, which is not only recipes, workflows that get from these data sources to that actionable information, but the mechanisms and frameworks that allow them to be redone and to be evolved as the situations change, which is critical for actually having useful information. So quick agenda here. I'll give you some interview and summary, and when you're completely tired of that, we'll turn to some demos. And we have a demonstration of the Geocollaborate client for leveraging both supporting that collaboration, which results in these recipes that we'll talk about, and in making available and useful and interactive the indicators that result from these recipes. Then hopefully we'll get Theo to join in here and show us a little of the AI-powered multilingual survey tool that he and his group have put together as part of the pilot that fits somewhere in between reporting and 911 and social media, but has, I think, the potential to play a really important role in finding out what actually is going on with people. And then third, a demonstration of secure geopackages. So much of the data that is essential in disaster management does have some sensitivities, and the necessary agile and sometimes connected nature of information flow in a disaster is problematic with a lot of these sort of access to data regimes. So this is looking at something called data-centric security, where the security goes with the data, not with a particular platform or system. And this is just a kind of a proof of concept of an approach using the offline form the OGC standard GeoPackage way to transmit and transport geospatial information. If we have time, we'll fit in a video from Dean Hintz on the flooding in Manitoba and how they developed models as a way to indicate what is, for example, passable in terms of transportation and what some of the health impacts might be. That video will also be shown next Tuesday in the final demo, and we'll talk a bit about that in the next steps and discussion, and do everything we can to preserve some time in this session to actually have some interaction and to have some discussion. So pushing on, status and summary. So the Disaster Pilot is an initiative of the OGC Innovation Program. Just briefly, the Open Geospatial Consortium is a group of 500 plus members, including ESIP and many ESIP partners. And one of their primary missions is to develop and publish open standards for sharing of geospatial information. models, formats, interfaces, practices, many parts around that. But those can't really thrive and provide value in a vacuum. So other important part of OGC is the innovation program, and that both comes up with ideas for standards, and so that's the kind of pre-sales engineering. And then once there are standards, what can we use them for? In many cases, if they're well-crafted standards, they are usable in many areas and for many purposes beyond what might have initially motivated their development. So the innovation program does pre-sales, mid-sales, and post-sales engineering and collaborative research and development for geospatial standards. There are a number of other parts of OGC, the compliance program, outreach program, the convening function of many OGC events, and collaboration tools. But right now we're going to focus on the innovation program and a pilot activity that we've been carrying out through this year. And this pilot, his goal is to really develop standards-based services and the practice of those services that really looks at rapid decision-making and supporting rapid decision-making through awareness and through actionable geospatial information. So 3 ways that we're looking to support that: to rapidly integrate, process, and transform particularly Earth observation and space-based observation data streams, but also others, spatial frameworks, other in situ or local data streams, but bring data which is in many cases far away from the disaster region to application within disaster risk reduction and management itself. And looking at doing that through understanding the relationship of analysis-ready data, so raw data which has been wrangled enough in advance to really be applied quickly to analysis and the production of indicators, information which are decision ready, which pertain not to the observations, but directly to the decisions and actions that need to make. What does that value chain look like? Who's involved in it? And what activity needs to be taking place along that? This includes open APIs, optimized cloud services to make this all possible at the scale, in the time and spatial scale that's needed, and in ways that respect that many disaster-struck regions have connectivity and capacity issues. And another item of, let's say, inquiry was optimized web search. How can these decision-ready indicators be published as structured web data, which web search engines are able to use to directly answer urgent questions, urgent localized questions for the public about what's happening and what to do. So this is the sort of bottom line. Instead of spending 80% of your time procuring and preparing data, let's spend more of it acting on it and less wrangling at the time that it needs to take place. So as any pilot activity needs to do, this has focused in time and in space and in terms of the types of hazards that it addresses. And while we believe and hope to show going forward that these capacities and tools are applicable to other hazards, these are where we focused in this activity. The scenario 1 was landslides, flooding, and pandemic impacts together in the 2 river basins in Peru, focusing on a historical interval with availability of data and occurrence of all 3 of these hazards. Now, scenario 2 focuses on the Red River Basin in Canada and Manitoba and considers flooding and pandemic impacts together. And then the third is focused on the integration of health and EO data and services in Louisiana. And this third one focuses on evaluating work that was done in advance of this pilot in a concept development study, which has resulted in a report about health spatial data infrastructure and a overall model for the health status, resources, and interventions that can support pandemic responses, but also other health, public health and population health activities. So that's focusing on this fit between what health data is available and what the model asserts is really needed for effective action. So why are we looking at multiple hazards and multiple disaster types? The reason is that we have tended in the past to look at one in particular as a means of focus, saying this is what's needed for flooding, this is what's needed for wildfires. And so two things are happening. One is that climate is reshuffling the deck on us. And so it's not only increasing the risk and impact of many of these hazards, but it is combining them. So, drought, a hazard, weather disaster leads to wildfires, environmental disaster, which leads to flooding and landslides in areas where those didn't occur before, which leads to displacements of populations and effects from and on the health of those populations. And these all combine together in linear and nonlinear ways, impacts on already vulnerable populations, limits to mobility and resources that were allocated or planned or provisioned for one hazard and then need to be spread thin to others. So the issue is increasing, although it always existed in the past, that these disasters cascade and complicate each other, and we need to consider them together as well as separately. So one important perspective of this pilot as a relatively technology mature activity is that we can put these things together, but what is the impact that they can actually have on the people who are using them? And in order to figure out how to improve that impact, the usability, we need to know to some extent who these users are. And these large-scale, agile, integrated information ecosystems that we are able to put together these days with open standards and with cloud capabilities and so on, means that many people and many different types of users can be involved. And so we've attempted here to understand who some of these people are so that we can both accommodate their interactions with these systems and empower their interactions with each other, so that instead of the data provider or the analyst saying, here's what you get, there's the capability for decision makers and responders to say, this is what I need, and for these conversations to be supported by this ecosystem, so that you might have a product provider saying, here's our wildfire product, and someone down here saying, well, I really need to know this in combination with some enhanced weather information, and I need predictions of the change over the next 12 or 24 hours. And that can go back through this mediation to the recipes for these products. So understanding the roles and responsibilities and the valuable interactions here is an important part of making this pilot in turn a valuable activity. So what are the problems here? This all sounds very easy, and it would be. There are lots of capabilities in each of these clouds. The problem is often these connections between the clouds, the pivotal interoperability points where data needs to flow in these value chains and often does not, or where this has not been set up or enabled with standards so that it's ready to go. And yes, we may be able to get a particular analysis-ready data set to the hands of the analysts and the relief organizations, but not for 2 weeks after the disaster actually strikes. So a large part of the work in the pilot has been to look at these pivotal interoperability points and see how they can be improved by preparation, by capacity building, and by the use of information tools to do this. So, and this is divided into particular groups that have been active in the pilot. So one of those is figuring out what is analysis ready data? When is it ready, not just from the point of view of providers, but from the point of view of those that want to analyze and integrate it? And how can cloud computing, so getting that data up into cloud platforms, getting these applications there along with the data, applications to the data, so that getting to the point of producing these decision-ready indicators, running these models, doing these integrations is a case of touching off processes in cloud environments and not spending long periods of time wrangling data into the right shape and the right location where they can be combined in this way. So the decision-ready indicators working through this, both these recipes for the focus hazards and the means of, with agility, taking those recipes and improving them in response to the situation and the participants. Then there's this publication stage of getting data to geopackages, to web search capabilities, and make these indicators available to the right people at the right time in the right situation. A couple of other elements here. One is that sensors and models are going into analysis ready data. So there's ongoing work which is not as mature as it needs to be, but has the potential to be so, to get from these raw observations and collection plans to data which is ready for analysis in a particular situation. That needs to be combined with, on the one side, that geospatial framework, which lets everything be brought together, and the reporting, which provides the enhancement and the validation of the remotely sensed data with locally sourced data as well. So we'll talk a bit about that. So here's an expression of this data to action value chain, where we have local situations and signs and situations that an analyst can say, well, we can use remote observations to, to enrich, empower this local observation to support responders and decision makers. And that is a process of transformation, of processing, and of value creation from these ready data sources through the transformation, normalization, standardization, making these actionable observations, but then being able to combine rules for action under particular circumstances, the hazard, the impact, the action that needs to be taken, the response that needs to be planned, to turn these really into indicators. And this has the role of being immediately actionable, but also still connected through tools such as Geocollaborate to the sources, to the basis for those indicators, so that questions can be answered about, is it really to prepare, or are we moving towards beware here? So simplicity for action, but connection to consideration. And so this value chain, the inputs to it the recipes for it, the usability of the outputs are part of the pilot mission. So here's an example of a recipe for some flooding indicators, and these have to do specifically with transportation impacts in terms of things like evacuation, resource provision, and so on. And these take inputs, datas, processing to come up with output indicators, and these thresholds give us a means of, as we say, color coding. Do this, don't do that, prepare for this. And there are many possible indicators. A large part of this paradigm is coming up with ones understood historically to be essential, expanding that in response to need in the situation, and changing them as the situation develops. There are now high clearance trucks available. We can use those, an indicator for those to find out where they can go and help rather than just cars themselves. Sorry. Okay. So, and that process of being able to adapt is really critical. So many times we've looked at data and tried to turn it into decisions and actions, and have run into these issues that needed to be negotiated between them. The spatial scale and resolution, the timeliness, particularly, we can get these wonderful leading indicators of land movement, which lead to landslides. But if we can't get them in time to act on the potential for landslides, they're just not very useful. Is it the right phenomenon, and are we, sufficiently sensitive to that phenomenon to give actionable information? And is this trustworthy? Do we have the basis of experience and authority and validity based on the integration of information that there is trust to act on this information? And as we noted, the security and privacy issues that always battle the availability of that information in a disaster. Yeah, very good note that these slides will be available. And I'll also, this is partly an advertisement for an event that I'll provide the invitation to next Tuesday, where we'll cover this information again. So just a couple more things, and then we'll get to the demos. So one of the difficulties is to make information available, and particularly to the public, where they may not have a lot of tools, but they can do web searches on their phones. And so this is a process of emphasizing, bringing that information up most visibly. This can be done through a process of adding structured data with this critical information to public web pages, which are then crawled by search engines, which are able to interpret and prioritize that information, such as, here is your nearest health facility that has capacity, or, your normal evacuation route is blocked. You need to take this route. So this leads to rich search results. And instead of in an emergency situation having to pore through multiple web pages, gives you the possibility of getting that essential actionable information right in your search results. It can be difficult to make sure that you're getting information about the facility or the location that is critical. And GS1 has helped us with a location resolution service that can also be integrated through web search into this process. So this is very much a work in progress and initial steps in this, but with this, I think, really important goal of making web search a tool in disaster management as well. So one aspect, another aspect of this, we've had so many sort of dimensions to this. And this is Marie-Françoise Voidreau's expression on this, that there have been a number of partnerships you know, recognizing stakeholders in this value chain means recognizing those who represent those stakeholders. And so we've set up monthly stakeholder meetings. We had one just on Wednesday with a large number of these groups that are involved, particularly globally, in this disaster preparation and response. And so we have this pretty large list of participants in the pilot, the sponsors and supporters, including USGS, Natural Resources Canada, NASA, and Peruvian Space Agency, CONIDA, but all of these stakeholders who have kept informed about the pilot activity and contributed their perspective to it. And we start looking at this network of relations. It's kind of overwhelming, but you know, here is ESIP down here. All of this is important adjunct to the actual technical innovation so that the innovation is directed in the right way and arrives in the right hands. So just quickly, things that you can take advantage of out of this pilot. So we usually create engineering reports, but sometimes those aren't terribly accessible. So what we've done is to produce a couple of guides that focus on that readiness, that, okay, we've done the wrangling, now you can act. Guides, and these guides, there are two. One is for providers, you know, how do you stage, position, and prepare data and resources such as cloud stores and cloud processing platforms so that they are ready to go in a disaster and ready to adapt in a disaster situation. And on the user side, what do users need to do? Because they need to be ready to take advantage of that as well. If the first time they hear about indicators based on satellite information is when they're standing there trying to evacuate people, that's not going to have its maximum effectiveness. So readiness is important on both sides, and these guides are a start, a living documentary way to start supporting that readiness. So these guides are published. I'll give you a URL for that and throw that into the chat as well when I can do that. There we go. And those also come with feedback capabilities. So we hope to get feedback from you and from other participants and stakeholders so that the documents can live and be updated. We hope on a fairly regular schedule so that they're, as guides, they're useful guides for action and activity. Great. So that's enough from me. And yeah, and really good point, Brian, that, that not only that availability of the indicator, but the ability to drill back under the right circumstances to evaluate the weight of evidence in favor of acting on that relevance and accuracy of that indicator is really important. It's not necessary that everybody do that all the time, but the indicators cannot be divorced from the source data and assumptions and so on that go into them. Cool. So I'm going to turn things over briefly to Dave Jones of Storm Center, and he's going to show us a bit about one of the collaboration and presentation, user-centered tools that has been involved in the pilot.
There was one more question in the chat. I think it was at the way top, and I believe your slides also covered those, but just repeating it once. So how does OGC define ARD and decision-ready information?
Okay, so those definitions are evolving, and I'll mention an activity to work on standardization of analysis-ready data. But analysis-ready data has two sides. One is that it includes the essential information from the providers about how that data came to be. But from the application side, it is organized in a common spatial and temporal reference and has normalization of common and phenomenal axes so that it can be combined with other information. So it's a readiness for both interpretation and integration that's critical. And the other thing is that it's applied initially to space-based Earth observation information, but we really have a need to expand that definition to many other types of observational information, and that includes model outputs. So we hope to expand what we mean by analysis-ready data going forward. Decision-ready information was the initial phrase, and then we turned that to decision-ready indicator. And as I tried to explain, our definition of that is that while analysis-ready data is generally observations of the natural world or the man-made world, the indicators are indicators for action or indicators for decision. So they're focused on those decisions or those actions. So the indicator will say, evacuate here or not. The indicator will say, here is what you need to know for deciding, as was brought up yesterday, do we put this forest fire out or let it burn? You know, what is the indicator which integrates a number of data sources and concerns do that? So analysis ready data is phenomenon focused. In decision ready indicator is decision focused, and that's a principal distinction. Please go ahead, Dave.
That was a mouthful, but that was great, Josh. That was really important. And as part of the pilot, it's been really phenomenal to be a part of the evolution of these definitions and to see how they're used and how they're absorbed by decision makers and users of this information. And so we get to, in the stakeholder meetings, get to present to those folks in Manitoba and Canada and in Peru and see what they think of the progress. So what I'm going to do is just show a couple of several slides here, and then I'm going to show you an example of how some of this data can be brought into Geocollaborate. And I just want to help to set the stage for where Geocollaborate fits into this pilot, because there's a lot of activities going on. Josh didn't have time to talk about everything in here with all this cloud infrastructure and cloud storage and health information and all that sort of stuff, which is a real focus of the Disasters Pilot 21. But if you see here outside of the circle is an acknowledgement that this has to be disseminated, and it hopefully can be disseminated in a way that this decision-ready information and analysis-ready data and decision-ready indicators can be shared out into mobile devices and into computers and web browsers and things like that that don't require somebody to install software. So this is where Storm Center plays a role in this disasters pilot, in the mobile awareness and reporting and the web desktop visualization and collaboration capability. And so this is how Geocollaborate works. You have trusted data out here. So think of this as the DP21 data sets that are being stood up in these geo servers that are providing as a source of data into Geocollaborate. And Geocollaborate can then turn on and off those data sources to any of the collaborators that are connected through the web. No installation needed. So they can start to get ready access to that analysis ready data and decision ready indicators to see if it's valuable in their decision chain, in their workflow, and then provide feedback to say, hey, you know, this is great, but can you have it available faster? Or can you change the colors of this? It's tough to see, and things like that. So Geocollaborate can create that environment where everybody's on the same map at the same time. And this is the area where DP21 really comes in with all that other stuff I just showed you and all of the efforts. So you have sensors and models coming in just like Josh showed, and then you have linked data, and you have geo packages and user working groups. So this is where this is also where we're coming in to say, okay, how can we consume this information? And keep in mind, it's a pilot, right? So just want to show you very quickly what Geocollaborate does. You can have a whole lot of data sets available in different websites or different portals or different hubs. And typically when you give briefings, you go through and page through a lot of different web browsers. And many of you may have done this in the past. So essentially what we're doing is we're extracting or pulling out those trusted data sets and putting them in a geospatial context. And so that can be done in a real-time collaborative environment. So everybody's looking at the same data at the same time. And then that information can be shared across any device. So now everybody really is looking at the same data and information. This is just the interface. I won't go over this. You have a leader, a follower, and a dashboard. And so I do want to clarify some terminology that has helped us explain what's going on, because people who create portals and hubs and websites sometimes feel a little bit threatened when they hear that Geocollaborate is coming on the scene to help to share their data. They think, oh my gosh, well, nobody needs our portals or hubs anymore. On the contrary, it's critical that they maintain those portals and hubs, because we're pulling out the REST services from those portals and hubs and sharing them in the collaborative environment. So how we really describe Geocollaborate is that we are unifying disparate data sets in a real-time decision-making environment. We're not integrating data sets into Geocollaborate. So it's really a very dynamic situation in which data providers could stand up data services rapidly, and then they could be ingested into Geocollaborate and shared across a whole decision-making stream to really enhance data trust, data usability, and ultimately decision-making that could come at many, many levels. So this is what I'm going to show. I'm going to show a split screen here with the leader on the left-hand side, this Geocollaborate, and I focused in on the Rimac River basin here in Peru, and the follower is going to be on the right-hand side. So I'm going to stop sharing here just for a second, and then I'm going to go back into share and share my desktop, my screen, so you can see what's happening here. So let me share again, and I'll share this screen. There we go. So now this is live. So now you have a leader on the left-hand side. We're here in Peru, and we have a couple of data sets displayed. And keep in mind, these data sets are being served by not a really incredibly robust server that's in the cloud and scalable and all that stuff. We're pulling it off of one machine. So it may turn on, turn off, may have to try it a couple of times to give it the signal. But on the right-hand side is the follower. So the followers can move their maps around, but once they turn Geocollaborate on, then their map is going to zoom down to match the leader's map. And they can also change the base map if they want to. They can change it to, let's just say they want a National Geographic type of base map, or just streets. They want to look at the streets there. So I can go into Geocollaborate and turn on and off these different data sets. So if I turn on the Rimac flood extent, then it comes on in the leader and comes on in the follower. And what you see here that I've just turned off and I'm turning back on are the routes that people can take because of the flooded area here, and take around the flood. So let me see, some of the colors are similar. So let me just go into, I'll I'll go into the National Geographic. So here the routes then show up on the map. I can zoom out and the follower will zoom out as well, and the data sets will display. So it puts the leader and the follower on the exact same map at the exact same time. So I'm going to turn these routes off again and then turn them on to see if they'll come on over here on the follower. But I also want to show you how we can interact with real-time population data. So we have an area here that's flooded in the Rimac River basin in Peru. And let's just say we want to know how many people are impacted by this. I'm going to go in real time and do a population extraction with this polygon capability. I'm going to draw this around the flooded area of this main location. And then Geocollaborate is going off now in real time to the NASA's Socioeconomic Data Application Center, CDAC, at Columbia University. And it's extracting the population in this polygon. So what you see just happened is that not only did it display the population on the leader's system, but it displayed the population on the follower's system as well in real time. And the follower can query this data. They can move over these bar graphs to see what the population is. And the leader obviously can do that as well. If the leader closes this data, it still stays open for the followers. But if the follower closes it, they can always bring it back at any time. As long as the population polygon is active here, then they can click on this polygon and then bring up the population. So let me I'll click over here. Oh, there's another layer that's turned on. So I can turn it back on and off, see if it comes in up over here. Oh, well, it looks like there's another layer turned on, but you get the point. So if I zoom out here from Peru, we also covered Manitoba in Canada. And I won't display a bunch of data sets here, but I'll just give you the idea and the concept of how Geocollaborate works and how it can pull in these disparate data sets and unify them together. So this is just a data set in Manitoba showing some of the COVID-19 counts, and they can be queried by the leader or they can be queried by the follower. The last update was just yesterday. So this is a real-time data stream coming on the status of health in Manitoba, and other data sets such as satellite imagery, radar data, radar sat, flood information, NOAA satellite data showing flooding and inundation areas can be brought into this and shared in real time. So I'll stop there. Josh, I'll turn it back to you. If there are any questions, I'd be happy to answer them.
Thanks, Dave. And yeah, we just scratched the surface of ways in which the Geocollaborate could be used. We hope to do some more scratching going forward. At this point, I'd like to turn things over to Theo Gudeman from the Gizmo team, which worked on this really interesting and potentially valuable real-time multilingual survey capability. So can I turn things over to you, Theo?
Yeah. Hi everyone.
And Patty, if you could make Theo a presenter, that would be great.
Okay. Got to get rid of this Zoom screen in the corner. It's the bane of all presentations. And present. There we go. Awesome. Okay, so hi everyone. Today I'm going to be discussing how we can bring open-ended feedback to the forefront of surveying in the case of disaster scenarios. This project was a collaboration between Gizmo, New York City's oldest GIS community, as well as my own startup, Basil Labs. And we're really grateful, Josh, Al, everyone at OGC for including us on the 2021 disaster pilot. So as my colleague Jin aptly puts it, today we're going to be talking about putting ears on the channels and feet on the ground. And actually, we're going to start with a demo. Despite the #1 rule for startups is to avoid live demos, I think the best way to show you this technology is to let you use it yourself. And so if everyone can tell me about their favorite ice cream flavor and why you love that flavor so much, if you can mute yourself, take 30 seconds, take out your phone, open the camera app, point it at the QR code, and then go to the URL on the screen. And if that's not working for you, you can just take that URL on the screen, answer the one question, click submit, and come back here. So I'll shut up and let's take 30 seconds. Okay, I think we're at time that 45 seconds. If you're still finishing up, that's okay. We'll check the responses at the end. So let me tell you why we're talking about ice cream and why that actually matters to disaster scenarios. All right, so why voice notes and why open responses? Fundamentally, our team thinks that open responses let you handle large scale information for the public as rapidly and iteratively. So let's talk about 3 scenarios here. While this definitely can never replace 911, there are scenarios where 911 might become overwhelmed. And a tool like this, where people can just talk to their phones, any language that they want, would be able to augment where capacity is falling short. So the value add for a tool like this is that it provides that no matter if it's one person or if you have 1 million people submitting, maybe not 1 million, but like depending on our servers, 100,000 people submitting within a span of 1 minute, we can scale with the demand. And if you're in a situation where you need to determine and allocate resources, classifying community input and mapping it to help provisioning healthcare so that resources are delivered to the right places. Okay.
Theo,
other
quick
ways.
question. There
Go for
are
it.
gray boxes that are obscuring a bit of your slides. Any idea?
Thank you. Yeah, I wanted to share. Let's share the specific screen here, but I wanted to switch Chrome tabs, and in order to switch the tabs, you have to share your entire screen. So here we go. Thank you for the note. Are we good now? I think we'll be good there. Okay, so going back here. Oh, okay. One more time. How is that?
They're in different places now, but they're still there. I guess maybe you just keep going and we'll figure it out.
Okay. Are they on the bottom of the screen or?
Bottom and top.
That's strange. Okay. Is it better if we're just in this mode? Everyone can see here.
Right now, it's fine. Yeah.
Okay.
Just continue.
So everyone, we're using Canva to make the presentation. Okay. So let's talk about deployment here. So what's happening actually when you deploy a survey? So we're deploying it to a specific geography. You can, for example, send out the URL via text message. You can have it posted somewhere, and hopefully before a disaster scenario, you can post QR codes throughout an area, letting people know that, hey, use this resource. When people are submitting to that specific area, people are saying whatever. We don't actually know what they're saying, right? It's open-ended questions. But with AI classification, keyword searches, semi-supervised learning, we're able to actually figure out what people are saying within their responses and then we can figure out how to prioritize resources and allocate them. So this is the process and shown in a different way, and I really want to highlight two specific components of it. Is that at the center of any disaster, you need the human component. And so when you have people submitting lots of responses, you need to be flexible. As a crisis evolves, you're going to have different people saying different things that you weren't expecting, that you couldn't have possibly accommodated for in a very, very long list of multiple choices. And so with this survey tool, the idea is that people can edit, adapt their survey questions. It's the same URL, people can still visit the same place. And then again, you can adapt the topics as they come in, as words come in, as people's responses come in. You can change the topics, you can shift them. And what that means for the mapper or the decision maker at the end of the day is that the map is updating in real time with new topics as people are saying new things that no one was expecting inside the command center. The second thing is that once people are giving specific feedback and we're tagging specific words and saying, okay, people are saying X, Y, or Z within these responses, we can send out very specific information to that user to say that, hey, it looks like you were talking about X, Y, and Z. Here are some resources for that. Within the larger ecosystem of where we fit, we're here to provide live on the ground information. And so our team has been very, happy to be a part of this project. And yeah, let's dive into where our team sees some potential applications. So if we're revisiting the first three use cases of this technology, let's think about why we need open responses. And really, the idea is that if we need to gather live intel on the ground, and we need to understand what's happening to people, we could make a series of short answers and a series of multiple choice. And our survey tool does have multiple choice and short answers. But the idea is that, can you reduce the number of questions that you're asking on a survey in order to increase trust within people responding, to increase the response rate, to let people say what you could have never guessed. And so if you're thinking about it, if you're gathering live responses from the epicenter to supplement other intel, first bullet point, we could ask questions like, what supplies do you need, right? We don't have to have a whole list of supplies, a check boxes to fill out. We don't need, people can just talk to their phones. The second one is, if you're thinking about something where we want to develop a common understanding between research practitioners and the public, not necessarily a time-sensitive issue, but we want to understand in a nuanced way, what's the public feeling? You could start asking open-ended questions like, how have wildfires affected your family? Or something that affects my own family up in New England is like, has seasonal flooding impacted your decision to sell or stay or move elsewhere? It's my family's from a fishing town in Gloucester, and a lot of people are moving away just because it's untenable. And so being able to understand nuances in the community is a key tool for open responses. And then the last part is that as things evolve and as things change, we can start to think about what's happening in your area. How have things changed? And that's just a very critical tool. It's not a one-time thing. It's an iterative thing that you're trying to increase trust with the public by showing that you're listening to them continuously, and ultimately prioritizing and geolocating these evolving issues. In terms of the tech, going into the tech side of stuff, what we're doing is pretty simple. It's taking a voice, an audio file, and we're first transcribing it. And then we are translating it if necessary for English for use. And then we are using keyword tags, as you can see on the right side of the screen here, or hopefully you can see the boxes. So we're using keyword tags to identify different words. This is actually a drag and drop interface. I'll show you on the next slide. And we are able to, if we are working on a specific scenario, use different semi-supervised learning techniques where you're adapting and you're adding different tags and helping the machine create its own training data set over and over again as you change parameters. And the whole idea is all of that goes to the database so that it can go to your maps and dashboards in real time. Okay, I just want to highlight that, fundamental to this project is that it has to be geolocated and it has to be open-ended, multilingual, so that we can really try and bring in as many people as possible to the process and then be able to map everyone's responses. So this is going to be small because I'm presenting here, but maybe we can increase that live. Creating a survey is really simple. I mean, imagine Google Forms, adding your questions, in this case, adding languages, filling out the survey that you just did. And the last part here, and let's see if I can pause it, is actually, I'll just show you live here. But you can drag and drop different keywords around to create topics. So looking at the surveys that we did at the very beginning, here's the benefit of having this open. We can go into our platform and do we all love ice cream? Hopefully the answer is yes. And so it's already tagging specific words that people were saying. These aren't words that I've made, just the machine identified them as important. You can start creating topics. So you can say that, like ice cream is not a good topic here, but chocolate, maybe we add like moose tracks into there too, right? And you can add a lane, you can add some, different things like moose tracks. I don't know who else, like mint chocolate chip, right? You get the idea. So we can add these lanes, we click set topics for all answers. And then the next step is we need to map it all. So in this case, I've already created a GeoRSS URL, or where we can access the GeoRSS. And we can plug that into something like ArcGIS Online. I'm not familiar with the new format for ArcGIS Online, so I'm still on the old. They always prompt me to go to the new one, but let's stay here for now. It's a safe space. There we go. So we plug that in. This is for the specific ice cream store. Oh, looks like we're running into a live error that, it's a issue here, but idea is that everything is going to pop up and you can see everyone's locations from where they were submitting. I'm not sure what's going on there, but we can give it one more go. And if not, we're going to move past the live portion and close out. Let's see here. Add from web. And I'll just double check that we're getting all of this correct here. Okay. Uh-oh, we're not doing this live today. We'll do it live tomorrow. But in any case, you can add it. The idea with GeoRSS is that you can take your map and then as you refresh, or you can set an auto refresh through ArcGIS Online or ArcGIS different platforms, it will update at X intervals, or you can set it to manually update. Okay, so on behalf of our team, thank you so much. And I really appreciate the time to present. Feel free to reach out to me. I've left it, my contact info in the bottom right. Thank you, guys.
Thanks, Theo. And maybe that will be working a little bit later. We still have a few minutes. I'd like to emphasize one thing that Theo touched on, which was, no, this does not substitute for 911. But on the other hand, 911 does not substitute for this. And it's a really important point that Al Leidner has been making, is that 911 was never intended nor constructed to provide, population feedback or to provide continuing, needs or requirements. You don't have somebody calling 911 every 5 minutes to say, how has the situation changed? Is the water deeper? So this really can fill a gap in the amount of, the information that a community or population can provide to contribute to disaster awareness. Sometimes social media is used for that, but as you know, social media's goal is not to do this. Its goal is to, accumulate eyes and make people angry. So, sometimes we can twist it in the direction of awareness, but very often its goal is not at all awareness. So this really has the potential to fit into this need in disaster situations that really is not filled by other tools at the present. So appreciate it, Theo. Let's turn now to keeping information away from people. And we'll turn things over to Andreas Mateus from Secure Dimensions to talk about data-centric security in disaster situations.
Yes, Josh, I leave you setting the scene. If you want to say a few words. And this and this. So what do you see?
We see a slide.
In presentation mode. Wow.
Yes.
Great. Okay, so welcome to my short presentation, and then we do a live demonstration on secure geo package. So basically, an attempt for a new approach for sharing trusted data that may be sensitive. This in the context of the disaster pilot 21. So as you already know, my name is Andreas and I work for Secure Dimensions located in Munich, Germany. The business focus is on innovative security solutions and GDPR compliance for distributed systems, in particular with geospatial information. On the next slide, a short summary of what a secure geo package is. It's basically an extension, no, it is an extension to the OGC standard called geo package. And in the extension, there are two things happening. One is there is an additional table that keeps key entries, so key metadata, and the actual data that you store in the geo package is encrypted. That gives you the ability to make sensitive information available with other information in a geo package. You can simply encrypt these pieces of information that are sensitive or shall not be shared with other people. At the bottom of the screen, you see two different sections here. One is for features and one is for tiles. So this is how it looks if you go as a techie into a SQLite browser. So what you see is data that is encrypted, and in the SQLite viewer that is labeled as a blob. So in this disaster pilot, two different extensions for geo package with encrypted content was implemented for features to keep back the data and for tiles to keep, as you may already guess, tiles or binary data. The entire approach is an uptake of results from the just ended OGC testbed, which is another project in the innovation part in OGC. So little more bigger figures and screenshots. And so from left to the right, you can see different activity areas or responsibility areas. So to the left, you have the stakeholders that provide information. And they can do that with a secure geo package service, which was implemented and deployed within testbed. Within the testbed, yes, but also within this disaster pilot. Then in the middle, you see the coordination center, basically. Their role is to create geo packages and distribute them, and also manage the access to the keys that you need for decrypting the content. On the right-hand side, you see different possibilities how a secure geo package can be consumed. So either you use application like QGIS or a web browsing environment. So for example, Geocollaborate could be used if it is enabled to distribute secure geo packages. Then you have the disaster support area, so on site. So you either have, for example, a mobile app called QField, or again, you have a browser. So all these different possibilities can be supported. So what happens is that the coordination center typically produces secure geo packages, which pieces are actually encrypted in the geo package is controlled via policies. So the resulting geo package can then be used and distributed. And the keys for that secure geo package to encrypt the content can be modified by the control center. So distribution to offline mobile devices. So you load it on the mobile device, you make it available to desktop environments or to other environments where you can use browser apps. So all these different possibilities exist. And the good thing about the secure geo package is it uses the standard geo package format. So existing programs, existing applications can load it and visualize it, but not the encrypted content. So this gives us the ability to share secure geo packages via email, file share, any way you want, and load it into an existing application. What is necessary is an extension to the applications to decrypt the content. And Josh and I are going to demonstrate that in a second. So thank you for that. That was my quick talk on what a secure geo package is and what to do with it. The additional slide here at the end is basically if you want to do this just by yourself. There is something that you need to do with QGIS, for example. So the regular installation of QGIS does not support crypto. So you need to install a Python module, which is called PyCryptoDome. And how to do that on Windows and Mac is outlined here. And then in the QGIS, you can just install plugins implemented in Python. And you can see these two links down here, are hyperlinks going into GitHub, where you can actually download the zip files and install those packages if you want to do this just by yourself. Josh and I gonna do a live demo of me being the coordination center in the middle, generating a geo package, visualizing that with QGIS, then sending that to Josh. He will attempt to do the same thing, but he will fail. He will not be able to just decrypt the information unless I go to the key management system and enable Josh. So that is the plan. Any questions so far? Perfect.
So I'm going
That's
to
what I-
show QGIS here real quickly. There we are. So hopefully this is familiar to people. And so Andreas sent me a geo package. Remember, that's an encapsulated file of a little SQLite database. So it can be transferred over the web, on the thumb drive, any way that you can do that. We haven't tried it with paper tape yet, but in theory, it's possible. And so I've loaded in layers. There's building layers, lines, points, and polygons here. And I can, for example, select one of these building points. But if I look at the attributes here, now there is, a simplified geometry here for navigation that's included with the feature. But the detailed data about this is not shown. It's just shown here as a blob. I'm going to copy that. I'll try to copy it eventually. Anyways, so if I go to the, it's just going to show a different window. But anyway, if I look in the plugins, I've installed those, encryption, decryption plugins that Andreas showed, but they don't have the right key information in order to decrypt this information. So you can, send and exchange this geo package anywhere you want, and without that key information, the person or tool that ends up with that is not going to be able to see that information. So it's secure against whatever system it happens to find itself in along the way. So switch back to you here.
Okay, so let me create a fresh geo package. This is going to be which window here? Oh, main Chrome, this one. Okay. So this is the starting point for the demonstration. So you see, this is a open API description of the endpoint of the secure geo package service. It is a plugin to a geo server. So what we need to do is we need to authorize first to create a package. So we need to log in to get a token. And we do that via the OGC portal. You can't see that because that's in a pop-up window right now. So I log in as with my account on OGC. And once I've done that, I get an access token here. So this access token I can use to authorize my requests to the secure geopackaging service. So below, you can see that there are two different options. I can create tiles and I can create features. So we're going to do features. The request is a regular OGC WFS 2.0 request with additional parameters. And you can already see, that these are, many are already prefixed. So these are already set in stone and you can't modify them. Here from the feature types, we're going to select the buildings. And we say we want 10,000 building features. Down here, we need to put some extra information. This one here, the key challenge, is our PIN to modify the key access later on. So, and then I can click execute, wait a couple of seconds, and then I have my geo package created. So I can download the file. It's a regular geo package. So that was portion number one. I'm going to send this to Josh while I continue working. So different application. QGIS. Where is QGIS? QGIS. Okay. So now you can see my QGIS, right? So and I'm going to load.
Yeah. So why don't you go ahead and do the decryption as well, just to save time here.
Mm-hmm. I'm chasing. Oh, it's down here. I'm chasing the QGIS window to add the screen, to add the layers, and it's again on a different window. And how do I get there? Too many desktops.
Might have to just share your screen. Yeah.
No, it's on a complete different desktop, and
yeah.
it's
The
a
bane of Zoom
disaster.
existence.
It's the disaster of this. I have way too many screens open. I cannot get to this. Risk. There it is. Okay, so this is the Geo package. So and you can see that what Josh was just saying. If I select a feature here, I can see exactly that. It's a different key now, but I cannot see the data. So to see the data, I enable the Python console. I go and select a few. Have I selected some? Yeah. Right. Okay. Yeah. So now I can go and use my access token from the generation of the secure geo package, and enter that. I hate these windows. Here it is. Too many windows. So you didn't see that, but I just entered the information, the token into the window for the plugin, and here you can see the decrypted content. It's not much, but I can see that. So I can visualize the access of this key by going into the key manager. So here I need to sign in, and I'm already logged into the token app, so I'm logged into this automatically. So this is the key that was just generated for the secure geo package. Here I put my PIN, and now I can see the conditions. So it's not shared with any users. The time is restricted until 6:19, so 1 additional minute, and then this key will expire. So, and down here you can set the area. So it would help if I shared Chrome. Okay, sorry for that. So here in the key management system, I can give access to other applications. I can share it with users. I can set the time. I can activate or deactivate the key, and I can give it a particular area. So I can lock the key used to a particular area. So now you saw that I can decrypt the content. Now, Josh, have you loaded your the geo package?
I was able to load it, but I think we should go on at this point.
Oh.
So it'd be good to wrap
Okay.
up. So yeah, I'd like to put this into a context right now, which is, this is very much a proof of concept. And, basically you have these three things. This is kind of like nerve gas, right? You have these components that are useless until you put them together. You put together an identity, a key, and the content. And then at that place where they go together, you can access and work with that content. So being able to do that under a variety of circumstances is very powerful. Clearly there's a lot to be done to make this really usable, and bomb-proof in an emergency situation. But this is the way that it can be done, that we can work out this goal of, making sure that the right people, but only the right people in the right circumstances, can access the right data. And you can be very fine-grained about this. Different users have different access. Some attributes are encrypted, others are not. You can have a generalized geometry, which is clear, very detailed, or microdata that is encrypted. So this is a very powerful tool. And now that I think we've demonstrated this concept, we have the potential to figure out how it really can work effectively in these disaster situations. So, this is always a requirement. Well, we have to make sure the data is secure. Well, this is an important way to go about it. So thanks very much, Andreas, for going through this. I'm gonna
welcome
step through a couple of last slides just to give everyone a sense of where we are. Unfortunately, we'll have to skip one of the demos, which is a flood prediction demo, but you will see that next Tuesday if you join our demo, and also will be in materials that will be made available, such as a YouTube channel coming up. So let me go to this real quickly. And I mean, this is a combination of wrapping up and answering questions. So feel free to plug in. So here's the information about the demonstration next Tuesday. You can register at this, and I will put this in the chat before we finish up. And here's just an overall look. So this is an ongoing activity. We had these precursor activities, the cloud platform and health SDI concept development reports, and those are both published now on the OGC website. We kicked off and we're now completing Disaster Pilot 2021 with these events. And we have these now questions we're trying to answer in sort of leading up to another phase of the pilot. So ARD standardization, I mentioned, effective and economical cloud use through batch processing that's multi-platform, which is, you know, cloud mobile, pop-up dashboards that make, you know, this provision of a dashboard, of a control panel activity more data-centric rather than organization-centric. And model interoperability is a big point as we look at models as observations, but also as continuing observation streams and not just one-off capabilities. And then an activity that we're starting on, but will continue, is we'll have feedback mechanisms for the health report and the process of updating that based on what we've learned, particularly looking at progressing into the specification of health SDI model that could be adopted in many jurisdictions. Meanwhile, we're putting together a call for sponsors for DP22 to start in the April-May timeframe. And as this shows, there's going to be close correspondence between a climate services pilot, which we had a sort of a kickoff, sponsor kickoff to this morning, feeding into the, you know, the risk and impact calculations and those complications that we talked about in the disaster realm. Both of these continuing together with the stakeholder community coordination, which will be led in this next year by Sarah Saidi from University of Calgary, who's just joined OGC staff. And so you'll be hearing more from her. These are some of those precursor tasks that I mentioned. You'll hear more about them. Some of what we're looking at, focusing on additional hazards, particularly climate impacts, working towards a more mature service architecture that structured linked data, but in particular, getting to more of a deployment, getting some of this persistent resources in place so that the agility of recipe formulation can really be exercised through this combination of available, fair, accessible, reusable data, and this cloud platform ecosystem. Now, working towards a higher maturity level by looking at how does this actually get transferred to practitioners through operational exercise and training use cases, linkage we talked about, and in particular, you know, an important challenge is rapid response. You know, how do we activate and traverse that value chain according to the constrictions or challenges in space and time that a particular disaster and particular actions and decisions impose. So those are pieces of the puzzle for Disaster Pilot 2022, and the call for sponsors presenting these options for action will be out shortly. So I think that's all I'm going to show. This is the climate services information, how one feeds into the other, the demonstration event, and I throw open the last few minutes for questions and discussions. One of the things that we also would like to work towards is a closer collaborative activities with ESIP members and clusters in the coming year. And so we're interested in ideas for that and opportunities for discussions, which we will be taking with a number of the relevant clusters. So thank you. Theo, any luck in the map presentation?
Nothing that we can show right now. We figured out what
Oh.
was going on, but it looks like there's a phone that said yes to sharing geo coordinates, but still came up undefined somehow. So we'll work through that, but definitely we'll let everyone know. Send out a map later.
Great. So that's a good case for resilience in the application. Any other questions, please? Thoughts, feedback? I've appreciated some of the questions that we did get about, for example, being able to drill back into the basis for an indicator.
Josh, you mentioned you would be sharing a link in the chat. Probably it was a couple of slides ago. It was mentioned in one of the slides.
Yes, so here is the link to register for the demonstration next Tuesday. Good catch. And let me make sure I send it to everybody. I'll try to make this an actual link.
Okay, it's fine. I'm going to copy paste this link in the notes. So if the attendees are going to take these notes forward, they can take the link from there as well.
Okay. Well, I hope that the people who've joined us today will feel free to reach out to me or other participants if you have questions or thoughts or interest in participating, supporting the next phases of this activity, you know, as sponsors, as supporters, as stakeholders, as participants. You know, I'm happy to talk about this and try to define some of those activities. Yes, the demo will be recorded and available. So yeah, if you register, we will make we'll send out links and information to those who register. So with that, I guess we're at 12:30 and we should draw things to a close. Thank you to Patty and Sahara Ali and to Susan for the support in making this possible. And we'll look forward to further conversations and events.